Hey everybody, this is Larry. This is day 26 of the February Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. Today I just ran 5K, just kind of keep it a little bit easy. Ran a little bit hard. I probably should just do more easy runs, but I just wanted to do it quickly and just kind of see where I'm at. Which is to say, not so fit. It's basically I was going my marathon training pace before 3 miles, and I was barely doing it. So definitely not in good shape, but not really optimizing for cardio right now. I think one thing that I found in training in general is that and maybe that you can relate to with Leetcode and all these things is that it's very hard to have it all. You cannot train for. Well, it's very hard anyway. Some people can. Some people are just like very gifted in some way, right? But it's hard for me to train for cardio and strength and everything at the same time. So it is what it is. You kind of do a periodization, right? Meaning that you kind of block off 3 months or whatever it is to focus on one thing, and then kind of so forth. So that's kind of what I'm doing now, and my running is just for kind of maintaining it so I don't lose it all the way. But it's still mentally a little bit tough to kind of see yourself like, and a little bit humbling to be like, wow, it wasn't that long ago I ran the marathon at this speed, but now I can barely run 3 miles at that speed. So that's kind of crazy. But it is basically what you put in. All right. Let's take a look at today's problem. We have a medium problem, so that'll be finally interesting, maybe. Hopefully not too interesting because I want to, take a nap. But yeah, today about 14. I feel like I'm very old because I feel like every other day I'm talking about taking naps. But that aside, let's take a look at today's problem. At 1404, number of steps to reduce a number in binary representation to 1. Okay, given a binary representation of an integer as string s, return the number of steps to reduce it to 1 under the following rules. If the current number is even, you divide it by 2. If the current number is odd, you add 1 to it. So it's almost like that, what's it, 3n plus... Is it 3n plus 1 rule or whatever? I mean, obviously it's not, but it seems pretty much more straightforward. I mean, definitely you can simulate it. I'm curious what the thing is. Oh, S could be 500. I guess that's the only tricky thing. In theory, I mean, even then, not really, right? Because if n is 500, and even if you shift every time and just doing this, it's going to be n squared. And n squared would be fast enough for 500. So I don't know what I do wonder if there's anything trickier that you can do. Not trickier, but just like, smarter in a way, right? So we have 1101. What does that mean, right? So if it's odd, meaning the last number is 1, then we just kind of, do we count the number of steps or whatever? So if this is a 1, if the last digit is a 1, so we basically have 2 rules, right? If the last digit is a 1, you basically have a carry bit that goes to the left, right? And you do a step. Well, you add 1, and by definition, after you add 1, you have a even number, so you always divide by 2. That's why maybe I skipped it a little bit. And it is a simulation problem, right? And what I mean by that is that there are no decisions. You don't make any choice. You just do what they tell you, and hopefully you do it in a fast enough way. So I think that's it. You just kind of carry 1, right? So you could do that in linear time because it's just carrying 1 bit, and you just check the math. So let's try to do it that way. I mean, like I said, you can certainly do it in n squared way, but I feel like that wasn't that tricky to get it down from n squared to whatever we need to do, right? So let's take a look. Here maybe I'll just write something like, you can write this in a number of ways, but we'll just count backwards is what I want to say, right? And maybe we have a carry bit, right? We have a count just for whatever we're returning, right? So then now if s sub I is equal I guess it is the whatever number it is. I'll just write it in a dumb way. So you have, this is the digit, right? and then digit we added to carry, set carry 0, 0, right? So then now, if digit is an odd number, then we did add 1, and then we add another one to carry, right? Otherwise, or I mean, but after this, it's going to be an even number anyway, so then we just do this, and yeah, and that's it, right? Right? Maybe not. Wow, I'm really well. Wait, what am I doing? Oh, reduce it to 1, not reduce it to... I think maybe it's mostly right, but I definitely did not reduce it to 1. Or this. So I have to be a little bit more careful, right? Because basically there are 2 cases. I'm trying to think about how to write this in a cleaner way, which, so this is 3 is, oh no, because it still tries to get rid of 1 until it kind of loops out. There are really 2 cases, right? Which is, which is that you have one cases where you have like a number like and then you just kind of loop through, and then the last digit is fine, you have no carry bit, and you know, and then the other one is if you do have a carry bit at the end, so you have someone like this, so then now this kind of goes to, you know, something like you know, after you remove these, then you have this left, and then you subtract 0 and you're good, right? So that's you have to do. Okay, so maybe we don't do the last bit, right? Because by definition, the last digit is always going to be a 1, right? So then now, if carry is greater than 0, if there is a carry, and it should only be 1, then now we just do one more operation, right? Okay. I mean, so that makes sense for these 2. What am I doing wrong? And also, by the way, this is why I say, you know, don't prematurely optimize. And what I mean by that is during contests, I would 100% do this and square, because I don't have to think about it. I don't have to debug it, or maybe I still have to debug it because I make other mistakes, but I don't have to worry about like weird cases, because, you know, it would just be much simpler. But, you know, just want to, this is why that is the reason. I put 5 steps. Why do I think there's 5 steps? So there is a carry here. Does this step not get called? Yeah, it doesn't get called, so that's why. So this is a second. Oh, no. So you have 1. This happens to the second to last step. So why is carry not 1? And thus, so why is carry 0? If this is a 1, so 1 plus 1, so now this is a 1, and then now you did 110, right? And then divide by 2. And then now you, oh, I'm dumb. I mean, I did the carry wrong. That's the short answer. I was thinking about this. I was like, there's something like really weird about this, because when you do something a long time, you're like, something feels weird about this, but I couldn't figure it out. And I was just like, maybe I'm just thinking about things. But this could be a 10. So that's what I was going to say. So then now is equal to digit by 2. That's basically what what's going on. Yeah, there you go. And I don't know how I missed that, actually. That's pretty bad. I was like, what am I missing? Something feels weird, because yeah, it's like muscle memory, but watch I get a wrong answer. Okay, thankfully, no. But yeah, but that's it. This is just like very much similar to any big integer problem of adding numbers. So adding two big numbers, kind of. So that's kind of the idea I was going with anyway. But yeah, as you can see, we can do it with O of n time, right? But like I said, maybe during a contest I would do it n squared, but not an interview. Though interview, you probably should take your time a little bit and at least do it. Anyway, that's it. That's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye-bye.